That's better, right? Right, yeah. My name is Dennis. I work here at the Tattoo Dude as a DevOps dude.
What about the camera? Did you turn it on?
Yeah, I turned the camera on.
Okay. But can I see you?
In the dark, yeah.
Yeah, so
Infrared, man. Go ahead.
at least this is all we will go with.
Use Photoshop.
Yeah, so my name is Dennis. I work here as a DevOps dude. We do shitloads of stuff on Amazon. Everything is Dockerized. We love Docker. And we use Lumen and Laravel for basically all our backend services except a few node services. What we're going to talk about, what I'm going to talk about today is how to centralize logging. I don't know how many people here bothers with logging. I mean, how many here is has over the extraordinary or other than the just normal logging on the server. Is there anyone having a proper logging setup?
Yeah.
Is there anyone not struggling with logging? It can be a bit tedious. It's not that bad if you only have like one or two monolithic services. But once you start to scale up, it's going to be pretty difficult to easily access these logs if they're placed in 5 to, let's say, 100, 200, 500 places, more or less. And by the way, we're hiring. So, why is it that logging is hard? Logging is, in its essence, is actually not that hard. You're just in your application, like, yeah, I want to log this because some dude messed up with my API, so I want to log this. So again, if you only have a single system, or only one type of a system, it's not that big a problem. But once you start to scale up, it gets more difficult. That said, there's tons and hundreds of different formats, sources, like application logging, network logging, infrastructure logging, access logging, error logging, all the kind of severity of types of logging. And everyone wants to log, but they don't want to pay for it. And when I mean pay for it, it's actually not just paying up, but investing time in having a proper logging setup. Because if you don't follow through, you can easily have a half-assed system that actually makes things even more worse than it is. I don't know if anyone is familiar with this. That's from text-to-speech, web scale, and MongoDB discussion. Really funny. Check it out on YouTube. So yeah, and why should we log? Obviously, we should log so we know where we fucked it up. But most likely, it's other people fucking up your system. So obviously, you wanna be able to respond quickly to these things. You have to be able to quickly. If someone calls you up at night saying, okay, this service is going completely out of nuts. It's not responding, or it responded some weird code. You need to be able to have one source of truth where anyone that has access can go in and figure out what actually went wrong. So obviously, it's really nice to be able to counter errors really fast and have them given to you really fast. But there's also a business side of it, gathering business intelligence, figuring out, okay, what of your application actually hit most? Where should we focus our effort in making this better? And you can kind of derive a traffic map. Let's just say like a regular access log. You'd be able to figure out, okay, what endpoints are hit most and with what data, and thereby figure out better ways to improve your business. And this is more or less like if your manager yells at you for some shit not working, you can actually show him that it's your partner that fucked it up and not yourself. And this is more like everyone that uses your API is by default out to destroy it. So in that case, you can also see, okay, what the guys that are consuming your API, are they actually consuming it correctly? Is there anything we can do to improve that? So these are just basically some more key points on why you should log. Then how should we do logging? Well, it's easy to just give all your ops and all your developers, just hand them your SSH keys to all your production servers and make them go in and tail that log if it's a problem. However, again, that's a really bad practice. I mean, someone could mess it up. No one from operations should ever have to know about why to SSH into a certain instance. So obviously that's out of the question of using. You have a lot of third-party tools that can handle this. A lot of these third-party tools are actually just ElasticStack as a service. The ElasticStack, I'll come to that. Where, for example, Splunk is used by Spotify. No, it's not Spotify, Shopify. Papertrail Loggly has a tight integration with Laravel. That comes with a bit. It comes with some caveat, like you are always reliant. You always have to rely on a third-party provider. You always have to rely on them to be up. You always have to rely on your own network to be able to contact the service. And when you set up these tools, as they provide you with examples, these logging actions actually synchronously happen. In that case, if you have an endpoint that produces some log and it can't continue, they can't actually push it to the log, then your script halts. And then in that case, you're like relying on these services to be up. Whereas a more proper manner to do it is logging asynchronously to an external stack by utilizing what mostly is always up on our system, which is the file system. And Laravel comes out of the box with logging to the storage /log/ whatever. So that's what we're going to utilize today, a bit later, to quickly talk about the ElasticStack. How many here used Elasticsearch for anything? So, but everyone knows what Elasticsearch is or have heard about it. Okay, great. So, to quickly go through it, Elasticsearch is a near real-time search engine. It's document-based, and you have a lot of tools or a lot of flexibility in Elasticsearch to get what you want. A lot of people use it for, obviously for logging, but also for other data, product catalogs, whatnot. You need to have really fast search queries on it. Logstash is another part of the ElasticStack. Logstash is basically a man in the middle where you have different beats. In this case, let's say the file beat here, it takes watches your logs and sends it to Logstash. What Logstash, the responsibility of Logstash is take some sort of input, which could be from a file, could be from the network, format it or pass it, and then push it to Elasticsearch. That's where all the formatting is. You have basic input, filters, codecs, and output. Inputs could be tons of things. It could be from beats, it could be from Redis, it could be from basically any other type of input you can actually retrieve data from. And the codecs is ways to parse it. For example, the JSON codec, if you get stuff in a JSON, is able to deserialize the JSON in a proper manner. There are like, I think it comes with around 30 or 40 different types of filters and codecs. And then the output, that could be also just a file, it could be std out, but in this case the output will be Elasticsearch. Then we have Kibana, which is basically a UI, and they also come with some query language, but mostly this is where it provides you with a web UI. You can go in, you can plot your data, you can discover your data, you can list it, you can aggregate it, you can do all these nice things. Recently, for a few years, this has been called the ElasticStack. This is basically because there has been a lot of varying versions of when these services get out. But they finally got themselves together and basically released a version 5 of all of them. So all of these comes in version 5, which are now called the ElasticStack. All the official beats of where the beats is basically one way to transport data from one place to another. The file beat, which we're going to use, obviously watches a file and pushes it through. The packet beat collects network data and pushes it, ships it to Logstash. And then you have metric beat, which collect metrics about your system, like RAM usage, disk usage, TCP connections, and that sort of stuff. And then you have some stuff for Windows. That's like some event, and I think it might be pretty nice if you dive into that stuff. Now, on a serious note, they have an official tool for Windows events and logs for internet application. So, how do we wire this elk stack up with Laravel? Laravel comes bundled with Monolog. I think everyone here that uses Laravel knows about Monolog. It's de facto, at least in my opinion, the best logging library that's out there for PHP. They adhere to PSR 3 log standard. If anyone is interested in the PSR conventions. And the only thing we actually have to do to wire to make Laravel ready for this type of logging is just to retrieve the Monolog instance that the Laravel boots with. Take the default handler. In this case, the handler that are bundled by default is the stream handler down to storage/log/whatever. That is the default handler. When you boot up a whole new application, you write a log. That's where the log goes. So we're going to get that handler, and then we're going to install a new formatter, the Logstash formatter, which does a bit of formatting on the log line for Logstash to better understand it without too much effort in have to modify how Logstash retrieves these logs in the end. So we're going to register that formatter, and then we're going to push the handler back in Monolog. In that case, when that is done, then you basically wired up Laravel for the next step to start with. So this is a basic ElasticStack setup. Over to the right, you have one-to-many microservices. This could be a lot of different microservices. In this case, I've just put up 2, but it will also be many instances of this microservice in particular. But this could scale like endlessly. So the idea is that all these microservices all ship with the file beat, software, which looks in the Laravel log files and pushes that to Logstash from all the APIs. And then we have Logstash who collects all the logging data from these. And in this case, because we already set up Laravel to format to be Logstash friendly, we don't really have to do much in Logstash other than say, okay, we want some inputs from all the file beats, and then just use the JSON codec and then push that to Elasticsearch. And then we can use Kibana to view all these logs. So that's what I'm going to demo. That's going to be interesting. Demo never works. That's one thing. Luckily, I have a sweet copy I can use if it goes to back. But basically, what I'm going to go through is setting up first just one microservice, wire that up in Docker Compose as what we want, and then further down in the Docker Compose, we're gonna specify the elk stack. So these would be placed, could be potentially be placed different parts of your infrastructure. In this case, I'm just using one single Docker Compose for simplicity. Yeah. Without further ado, I think I'm just gonna jump into the demo. I need a small drink roll first. So does anyone have any questions so far? I know it might be a bit too early, but any questions, anything I missed particularly? Okay, great. There we go. So yeah. So you can see here, this is my lab. This is basically where everything is going to live in a moment. I've cheated already these three configurations because I thought that would be maybe a bit tedious to go through. These are I'll mention whenever that's appropriate. The first step is to create a small service in Laravel, configure it to use the log/stash formatter, and then write Docker Compose to support the application. That's the first step. So I'm just going to get to the live. Create a new content API. There we go. So we have the content API living in here. So to go back, these are basically the 4 steps we're gonna do. We register that in that service provider, the one that comes bundled with basically where the best practice is to register all your handlers if it doesn't gone too viral, your application, unless you obviously will have your own service providers. But these are just the service provider that are bundled with Laravel. So we're just gonna import so the first thing is to get the non-log instance. And then we're gonna get that default handler right here. Then we're going to register that new handler, the handler with the formatter we want. Right now it uses the default line formatter, which would basically just put a default line in the log files. I'll show you the exact difference of these two types of formatters. In this case, I'm just going to wire out this pretty quick. I'm just going to explain what these do in a minute. And then push the handler back into monologue. Yeah. So now we basically wired up the content API. That one is ready. Whenever I'll just quickly create this one now. Let's just say whenever we hit this, this is just a default route. We're gonna put an error message and something like search speed. And these are additional fields you can use, basically the context fields. And what you can see, what I did here, if you disregard these 3 parameters, this one in particular will, this is the prefix for your context stuff. In Elasticsearch, you have these preserved words like type, index, stuff like that. So this is a measure to make sure that all your context you send with the log is prefixed with this so you don't accidentally clash up against an index. So just for a small part. So there we have that. So basically, if we go into okay, that didn't go well. I'm not going to do the Tinder one then. Fuck, I removed the XT-bug, that was not a good call. Regardless. Okay, the next thing we're going to do is wire up the Docker Compose. So the Docker Compose in this instance is just going to be a set of an Nginx image, a PHP image, and obviously the source code in a BusyBox container. And yeah, we'll have that up first, and then we can see that running. Does anyone here not know what Docker is or Docker Compose is? Everyone is okay, familiar with it? Or yeah, okay, great. I'll just go straight into it. So just clearing version 2. Is this big enough? Yeah. So the first thing we're going to put up is the actual source code. So the content that is a BusyBox image, we're going to mount this content object here to our UV site. That's basically the source code. Then we're going to do the Nginx container. Nginx, that's the image is Nginx outline. That will have volumes from content. And this is where we do, one of the microservices will be on a local host port 88, so port 8080, and the other one we'll put that at port 8081. But again, obviously these microservices should be in their own ecosystem, but for simplicity I'll just put all into one here. What we want is for 8080 to port the inside. Then now we have the Nginx. No, actually, I cheated a bit by making this configuration. This is just a really basic Nginx configuration for a PHP application. I think this is basically just like the first result you get when you search for Laravel Nginx building out. I actually think I stole this one from DigitalOcean. So sweet, we have the Nginx one up. Then we're gonna wire up the PHP FPM for it. Image is PHP. If you're curious where I get these images from, these are basically just these are the official images. So they are as bare bone as it can be. So here the Nginx and the Alpine one, I just use that for CI. Actually, I already made an error. That's the Alpine. Sweet. And the PHP one, just make sure I got that one right. Also just the official PHP container. And what we are after is basically FPM Alpine. This one will revert to version 7, which we like. So that also needs the volumes from content. And obviously, to configure Nginx, we need to have this configuration inside the box. So I'm just gonna mount that. Else we'll figure out it's going to blow up if this doesn't work. And then we fired up the PHP one, and I think that's basically one for the microservice. This is without the file beat, so let's try spin this bad boy up. Try to compose. Oh, crap. Right. Okay, yeah, so what now the problem is that Nginx doesn't know about content PHP, so we're gonna have to link that. Links. We're gonna link content PHP to PHP inside. And that I do these two different names because in the Nginx configuration I actually pass this through TCP to that instance of the container. Let's see. So now we should be able to crap. That is what it did. This is why that never worked demos. Yeah, great. So basic figuring out I did a mistake.
Yeah, we did that. Just waiting for it.
Come on.
2M.
Yeah, 2M
There's
and
the next
then
line.
last folder, V1.
Down. Yeah.
Thanks.
This one.
Oh yeah, great. So
2M.
so if we look in the log for this one now, Laravel log, not that one. Yeah. If we just delete this quick, comment this stuff out. So this is basically completely default. This is how the string looks. You can in Logstash do a filter that to extrapolate these things out. But I'll show you how it looks when it's actually already formatted for Logstash, and you can see it comes with some a bit of metadata. You see that? Yeah, so this log line contains a bit more information, but this is all to help Logstash out and to not force yourself to do some mapping stuff and filtering. So we delete this one. Now we got basically the one of these bad boys up, except the file beat. I'll make that one up. But we have the Nginx, we have the PHP, and we have ourselves correcting Laravel. So now we're gonna put up the file watcher file beat, which is gonna look in this log file every time new stuff comes in, and then it's gonna push that stuff to Logstash. So if we file beat. Or find stock. And that also needs the volume from this box, as this is where the log files will be. So one. And because this image actually already comes with the default configuration of looking at /filebeat.yml, so we're going to mount that. But first, I'm just going to show you this. This is basically all the configuration is for file B, in this case. So I define, the first thing I do is define the output. Obviously, this doesn't exist as of yet. I'm going to create that in a moment. But the most interesting thing is this one. So this is just a standard glob for where you want file B to search. You can have multiple of these prospectors to look at different places on your system. For instance, this will be the application log. However, there could be the sys log, it could be the RC log, it could be different things. But basically, it's going to look through whatever the path you define here, and then try to push that to logstash. So I'm gonna mount this file inside this container. So now that one is fired up. So this is basically our done. A done microservices. This is what a really simple microservice could look like in the cloud if it's based on Docker task definition, or if it's like multiple software in one container. Basically, what is like the whole microservice in itself with the components that it might have. In this case, this is 4 different images to result in that one microservice. So all this is up now. It's ready basically to ship that stuff to Logstash. But if I were to fire up that stuff up now, it wouldn't work. Obviously, we don't have the Logstash yet. So you can imagine that this is a completely different place in our infrastructure, or completely separate. In this case, we're just going to have it in one same for simplicity. So we want to have a Logstash, and the image for that is basically just Logstash F5. And as mentioned earlier, all the versions of the ElasticStack has been aligned. So you can say that like you are able to use the whole version 5 of all the software they have, whereas before they were kind of deviating a lot in the versions, and they had a lot of incompatibility problems of some versions to some versions, and people never really was satisfied. But they finally got the shit together and released the version 5 of all the stuff. So that's what we're gonna tinker with. So Logstash, and then we need a Elasticsearch. That image is also just Elasticsearch. These are again completely official Docker images that they put out themselves, or have someone paid to do, I don't know. But these are the official images, so they come as bare bones as possible. Before going to Elasticsearch, there are also some configuration for Logstash, and I cheated a bit there. It looks like this. So basically, if you go back to this stuff, input, filters, codecs, and output, all that stuff are defined in the Logstash configuration. And as you can see, I have input, and this input is going to be from my file read, and by default it uses port 1543, and the codec it needs to use is JSON. If I wouldn't use this codec, it will just come in as one long string, and you wouldn't be able to filter on specific fields or values or keys for that stuff. So as you can see, I'm not using any filters. I'm basically just using an input with a codec, and then I have output. And the output in this case will be Elasticsearch. And these are also just the default port. Elasticsearch comes out of the box. This host name is yet to be created, or I'll create that in a moment. First of all, we need to configure Logstash to use that to use that configuration. So again, logstash conf, just mount that stuff straight in there. And then because the image of logstash come with a rather unorthodox standard command, we're gonna override that. Basically, that's logstash.conf. So when this image starts, the entry point for logstash will be its own binary, and then we just append -f for only to use this configuration. In a larger setup, you wouldn't just have one logstash configuration; you would have multiple. So in that case, you would not write this one. You would just add all the configurations into their default configuration directory, and those will be automatically picked up. But in this case, we only need for it to know this file in particular. And this one will need to be linked to Elasticsearch. And just a quick mention, the links here is basically what hosts are this container able to communicate with by what host name. So when I say that I have links, Elasticsearch, that would mean if I were to jump into the logstash container afterwards and look in its host file, I would actually get a weird auto-generated IP, but with a nice logstash, a nice Elasticsearch host name. So I know that inside the logstash, if I curl a ping with just Elasticsearch, I would know it would resolve to the correct IP. So Elasticsearch right here, and then we need. Then we just need Kibana on top. I don't think I missed anything there. Nope, straight out the box. So Kibana, again, completely the default image. In this case, Kibana comes with Kibana will be the web UI to browse the logs we eventually going to put into Elasticsearch. It comes out of the box with the port 5601. So I'm just going to map that port straight to my host system. Great. And that one will also have to know about the Elasticsearch, so we're going to link that stuff as well. So if I haven't messed anything up, that's basically just our stack, and we have our microservice up here. So if I didn't mess up too much, we should actually have a setup going. I want to just kill this off. No errors so far. We should be able to have some sort of message in the log saying went from yellow to green status. That basically Kibana keeps polling logstash to make sure you see status went from yellow to green. So I should be able to go here and 5601, and now we have Kibana. Kibana is a whole different tool. Momo's gonna go through a few dashboards, right? Or, later, so I'm not going to go into much depth with it. But basically, when you put stuff in Elasticsearch, you have indexes, and you have to have optimal performance. You have to be very careful about the indexes. I mean that's something that a lot of people, they just have one index for logs and then they just ship all the stuff in there, but it ruins how Elasticsearch works with shards. Not something I know that much about. So in this case, we have to start with creating an index. But because we have no actual data in Elasticsearch as of yet, there is nothing to create an index for. So if we just, we know that this is going to reduce a few error messages. If we look in the log here, and then we should see, you can see FileB does some madness stuff here. And if we then refreshing here, I should be able to create a new index out from the timestamp that is in the log entry. And then I should actually be able to discover my logs. And here we are. Here it is. So there's a lot of information here. You can basically wire up entirely how you want with the context data, depending on how much flexibility you want. But you can always be sure that you have the levels, you have the actual message, and you have the context, and then you can wire up whatever dashboards or more stuff that it needs. And you can see here the host is a content API, where we ought to kind of create a whole new API because now it's just one instance. So if we just quickly copy container to image API, settings, go here, make sure the image API search providers. Image API. Image API. And we go into the compose, copies all this stuff. Done with that. And we make our own little image API. Cheating a bit. And then we obviously have to put that on another port because content API it takes 8080. Just that stuff. And I guess we should do a bit of a different. And then we can put that as a critical step. And let's spawn it up. Kill it. Just clean up these. Now I should both put up my content API, my image API, and obviously the ElasticStack, and we should be able to trigger the error on both of these applications and have it both in Kibana for us to go through. You can see, obviously because I also copied the log file, so it just actually added all this stuff in it. It should be good to. This is our content API, this is our image API. That's on a few errors now. We should be able to see FileB picking that up in a minute. There we go. And then we should have the logs over in Kibana. So just need to create the index again. So now you have, this is from the image API, and we have stuff for the content API. Go. And you can easily sort between these two queries, do whatever. Kibana has a whole rocket science in itself. Yeah, that's it. Does anyone have any questions, or I mean, I'd be happy to answer.
minutes going to talk about how you actually do it afterwards.
No, it will be very, very short, just to show you what you can do with Kibana.
Yeah, that's going to be from the Kibana interface.
It's going to get your data? Or?
That's going to be on our production data, right?
Yeah.
Okay.
James, is it okay with you?
Don't steal any tokens, though. We don't use these version 5 in production, so the UI is a bit more not as good. But yeah, you have a few dashboards and stuff prepared. But according to how it actually happened, is that because did I miss something?
No. I was going to ask some questions about like how much data you have in your system, and then I thought maybe I would make more sense to ask them after.
That's great.
Does anyone, is it interesting to have the code? Do you want to share the code with the guys if they want it?
Yeah, sure.
That'd be really awesome.
Yeah, for sure. I mean, I'll put it up on my GitHub, and I'll put the slides up. I'll post it on the Meetup channel.
Yeah, that'd be awesome.
We run everything in Docker.
I mean, not everything. On the production scale, all our microservices are Dockerized, but our databases are running on RDS instances, and our log-stash servers and our access points and our bastion servers and our documentation side are not Dockerized. I mean, it could easily be doing, but it wouldn't actually solve any problem in that case. And specifically for the databases, there's not that much reason in running anything in Docker, because your database are not supposed to be portable. However, in development environment, staging environment, it's awesome. But so we do run everything more or less in Docker on the developing environment. But in production, there are certain artifacts that does not make sense to run in Docker, as it doesn't really solve any problem. And also because we do use the RDS services, so we don't actually handle the actual server the database are on. We just post some strings and they spawn to new servers. Yeah.
Do you also have like triggers that kind of start processes based on certain type of errors that occur, like people get notified or things like that?
So you can set up these alarms in Kibana, which will be which is pretty normal. But what we do instead is we don't base our alarms on the on the actual logs. However, that could be easily done, and most likely because you have more advanced queries, so you can do some more advanced alarming. But in this case, we have alarms on like too many 500 errors. But it's not based on the logs. That's actually based on the load balancer access logs.
But it is definitely possible to create any kind of alarm.
Exactly. And I know there's a lot of tools that also helps with these types of alarm based on logging. That is definitely a valid option.
How's your workflow? Are you using Forge or?
For our APIs?
Yeah.
We use no, we don't use Forge. We use we have it all Dockerized. So the orchestrator and the schedule we use is Amazon ECS. And then we have pipeline through a code ship, a code integration, and then I suppose I can show. So basically, our stuff is what happens when we push to ECS. Is basically that these container definitions. This is like Docker Compose a bit on steroids, but then completely messed up by Amazon. But this could potentially be a Docker Compose file. So this hooks all that microservice together, and then when in Amazon we have these container services where we have our microservices. These all represent one microservice at itself and the amount of tasks and containers running in that cluster. So we don't use Forge at all. However, it is pretty nice for personal projects, but it does come out of hand on a grander scale. I mean, so we basically only have use Docker both development and on production. Yeah.
Is your development setup Docker as well then?
Sorry?
Did you just set your development setup?
Yeah. You can see this is the development setup for this API as in itself, and we have the database and the reverse proxy, and then the PHP container, and basically our PHP container actually or our source code container comes bundled in the PHP container, and then the Redis. But these are in production replaced by production valued services.
Do you just use it on your Mac, or do you run it inside a Vagrant box or anything?
No, I mean I actually used the new Docker for Mac. Okay. However, it's basically always been the same. If you're not on a Linux box, you will always have this virtualization layer, and then but like in last year, it's just become more and more transparent. That layer they came out with Docker Machine, where you then just assign your proxy. You actually assign a proxy behind this virtualization layer, which is a virtual box or an Amazon instance or not. But in this case, I actually do just have it proxied straight to this one. Nice. But it is the same as Docker Machine is before, and now they just made a GUI for it.
Yeah. You said the Logstash is asynchronous, so I wonder, do you ever lose data, or do you have any data lag?
Yeah, I mean, that part is not asynchronous, because Logstash is definitely synchronous. It's how Logstash gets this log. Where if your application did a straight curl call to ship the log every time, that would be a synchronous operation. You'd have to wait for a network to respond and all that stuff. And so by asynchronous logging out, I mean that Laravel just still logs to the file. So your application will not suffer anything. You always log to that file, and then you'll have Logstash picking that up and put it. And if we would lose data if let's say we tried the Logstash server running out of disk space. In that case, it would actually buffer the data from the file clients will buffer the data until Logstash is able to handle it. If Logstash are not eventually able to handle it, I think it just discards it. Or I think that's kind of what makes the server kind of go out of, spin out of control from time to time. But there is potential to lose data.
Yeah.
But there's also worth mentioning, not much effort has been gone into to enforce that we never lose any data in that case, because I mean, obviously it's nice to have the data, but the data is kind of disposable. We don't use these logs for something that are completely business critical. If we were ought to do that, then definitely we will have multiple Logstash instances, which could fail over to, we'll have more measurements going into that no data would be lost whatsoever. But right now, if the Logstash goes down or anything, the file clients will just be buffering up all the data, and once Logstash is ready to handle new data, it will just swallow all of it and then pushes it through. And if you don't make sure that it's able to process that data, the server will eventually crack down. but best practice is to have 3 to 4 Logstash instances running if you want to be completely fault tolerant in that case, and then you can actually have multiple masters of that one. This is really, really simple scale. Also because Elasticsearch rarely comes in like one box. You have different master nodes, and you will have query nodes, and you will have data nodes, 3 components. So if you scale up it insanely, you have to have multiple master nodes that kind of only takes in data. You have the data nodes and only stores the data, and then you have the query nodes for other consumers to be able to query without any performance degradation.
Cool.
Yeah.
What kind of approach have you been using for the database? Not for this, just for the application itself.
The approach, as in what services
Yeah,
or
so you use MariaDBS, and you use like called cluster solution with
obviously not local in the staging environment. Actually, we do in the staging environment, but no, that we haven't set up these Galea clusters ourselves. We have Amazon RDS. That service handles multi-AC, always have a standby instance in another availability zone, and you can easily create read replicas and then load balance through them through the DNS layer, which is basically what we do. So we have a master connection, a write connection, and a read connection, and you can have multiple read connections, always only write to one master, and that way we actually scale it up. But we actually pay Amazon quite a few bucks to handle that for us. Eventually, to our own solution, to be able to harvest as much, money for value, because you definitely pay a bit more to not have as much access, but more or less having them being responsible to scale up and scale down, apply maintenance, windows, patches, and all that stuff. But now currently we use the RDS services that handles all the clustering almost automatically.
But just to add on the database, we're also using Elasticsearch not only for logging but also for storing data. We have some data that needs we need to do some kind of complex searching operation on it. So we're using some of our entities we're storing them in Elasticsearch as well.
So we basically have all the flat data, all the relational data in the RDS database, and then we denormalize that data into Elasticsearch for the consumers to query much faster than it would in a relational database.
Also restructure the data in Elasticsearch.
Yeah, we denormalize it, so it's we do that with our application users and posts they post.
Yeah, we got some news and articles, we want to search for that.
Yeah.
Whenever there is a full text search, where there is a redundancy involved, then it's better to go with Elasticsearch.
And you'll show that, right?
Yeah, I will show some of it.
Yeah.
So,
Sweet.
maybe the guys have some more questions.
Yeah, we should do a 2-minute break. Or...
Yeah, definitely. I'll show you a secret. Great, thank you.
Awesome.